How does a micromotion Coriolis Flowmeter measure mass flow and density? The Flowmeter has dual parallel flow tubes. When the process fluid enters the sensor, it is split. Half of the fluid passes through each tube. During operation, a drive coil stimulates the tubes to oscillate in opposition to each other at the natural resonant frequency of the tubes. Magnet and coil assemblies, which are called pickoffs, are mounted on the flow tubes. As the tubes oscillate, the voltage generated from each pickoff creates a sine wave. The sine waves generated indicate the motion of one tube relative to the other. When there is no flow, the inlet and outlet sine waves are in phase, meaning they are in a synchronized motion. When fluid is moving through the sensor's tubes, Coriolis forces are induced in both flow tubes. These forces cause the flow tubes to twist in opposition to each other. As a result of the twist in the flow tubes, the sine waves are now shifted in phase with respect to each other and are asynchronous. The time delay between the two sine waves is measured in microseconds and is called delta t. Delta t is directly proportional to the mass flow rate. The greater the delta t created by the Coriolis force, the greater the mass flow rate. While the sine wave phase shift indicates mass flow, the wave frequency indicates density. When the liquid density changes, the vibrating frequency of the tubes also changes. Consider an example of a spring and weight system. A larger mass has a lower frequency of oscillation, while a smaller mass has a higher frequency. In the Coriolis sensor, the tubes correspond to the spring. The mass of the tubes and the fluid they contain correspond to the weight at the end of the spring. The stiffness of the flow tubes remains essentially constant. Therefore, the mass and density of the fluid contained in the fixed volume of the flow tubes is the only variable affecting the frequency. Liquid volume flow is derived from the mass flow and density measurements already acquired. As in this example, fluids can have the same volume, but different densities and masses. The mass and density measurements allow the calculation of the volume flow. Using these techniques, the micromotion Coriolis meter delivers highly accurate, direct mass flow and density measurements in a broad range of applications. To learn more about micromotion Coriolis flow and density meters, visit micromotion.com/Coriolis flow.